got it. No,
you need your math reference book, and Ellie, I'm going to put you with Sam and Grace today. Good.
Maddie always
You need your math reference book, and you need to be with your partner. And you need to get out this sheet. Yep. Lauren, Ellie, that book is Lauren. Please put that where it goes. 9 times 4. 36. Okay. Who passed out work? Let's go ahead and look at our target sheet for today. Keep in mind, you've got targets for the lesson and then ongoing targets. And oh, what do you know? That just so happened to be a choice for today during math intervention.
Oh.
And Ellie and I did that together today, actually, believe it or not. Because if you look at what today's learning target is, I can solve multiplication and division back, mental math. What do you think you and I did the whole time during intervention?
There's no 9 times 4. There's 8 times 4. There's no 8.
Okay.
Isn't 8 times 4 one of my downfalls? Yes, it is. No, it's
No.
36. No, that's not 36. No, it's not.
Okay.
8 times 36.
So that's one thing from today.
36.
And that's actually the only learning target today for 11-4 that you were responsible for. Get out your math reference book, and I need to borrow one.
Borrow mine. Here you go.
Thank you. And who are you going to sit next to so you can read on with them?
Ellie, you are my partner. Right.
And Sam. So Sam, you need to go to the round table.
This is what I'm talking about.
Although if Sam goes to the round table, then that's way too many people at the round table. That's gonna.
And there's just enough space in the cup.
I'm going to say all three of you move to the hexagon table. That clears that up.
Coffee table?
Nope. Okay, open up to page 137.
What?
Your student reference book, page 137.
Tell them over here that. Now Jackson is in the top. Ooh,
so here is your math message for today that you can discuss with your partner. Page 137, and you only need one book per partnership, so whatever you want to share. Here is the question. Be prepared to explain why there is a picture of a sandbox on page 137. So share that with your partner. Why is there a picture of a sandbox on page 137? We don't want to be breaking the rule of getting goofy.
I know, but I think that because everything doesn't always follow that.
That's right. So look on page 137 and tell your partner and be prepared to explain why there's a picture of a sandbox.
I don't know why there's. I don't know. So we're measuring. You know why that? Well, you have to talk.
Okay, who's ready to share their answer?
Zach just talked.
Yes, he does need to talk, actually. It's on pause right now.
Oh, it was?
Yeah, during math, because you do need to talk. So, who has an answer?
I have no clue.
Somebody who has a hand up. We don't need public service announcement on if you have no idea. Gracie.
Isn't it we're gonna be measuring how much you can put into a cube?
Yeah, so something along those lines. Okay.
Oh.
Volume?
Antarctica. Gavin?
Well, it says volume and capacity.
Capacity.
Oh, capacity.
Uh-huh.
Because volume is the height and capacity is the space.
Very simple. Okay. So let's go through and read this. The volume of a solid object, such as a brick or a ball, is a measure of how much space the object takes up.
Yeah.
The volume of a container, such as a freezer, is a measure of how much the container will hold. So the volume of my water bottle is how much what? How much what? Now we don't even need what the label would be. It's how much what this water bottle can hold. How much water? The water. So the volume of this is how much the water bottle can hold. Volume is measured in cubic units. A base 10 cube has sides that are. So I'm going to pause and partners send one partnership up to get a cube. Come and see me for a few longs and come and see me for a few. So everybody needs to have one of these, base 10 blocks. Go get a base 10 block. Okay, that's for you and your partner to share, okay?
That's not a lot.
No, it's not a lot, because you and your partner, not candy.
Are you filming it right now?
Oh, you are?
Getting the bread fish.
Yes, it is.
I am.
Oh gosh, where'd that go? Come, I'm sure it'll turn up.
What's this website anyway? Okay.
Here.
But you're getting like this.
Did you get longs? You
Yeah.
have longs. You have longs.
In this scenario, on math boxes, I found the answer with Jackson. It says how many squares can fit in this box.
Yeah, and there's one you need of that. Okay. So, me too. I think it's something across the office. Oh, it's Gavin. It's hard-boiled eggs. Okay. All right, so, volume is measured in cubic units. And here we go. This is literally what we're talking about. So, if you don't know where your eyes should be, look at my finger. A base 10 cube has sides that are 1 centimeter long. So here's your centimeter cube. It's 1 centimeter long. It is called a cubic centimeter. A cube with 1 inch sides is called a cubic inch, which I need to go get those.
The cube that we have matches the cube on the thing. Oh, it's his actual size.
So 1 cubic centimeter and 1 cubic inch, which we don't have those because we don't have cubic inches in our math tool area. Chloe?
When we did this with Mrs. Stillman, she like.
Oh.
Okay. Okay, I'm going to keep going.
Okay, sorry.
Okay, so we don't need to know so much about this. All I want you to know is that why the Sandbox is on here because, well, let's read the paragraph. The volume of an object can be very useful to know. Suppose you wanted to buy sand to fill an empty sandbox. To estimate how much sand to buy, you would measure the length, width, and height of the sandbox. The length, width, and height are called the dimensions of the box. You would then use these dimensions to calculate how many cubic feet or yards of sand to order. Which, believe it or not, happens in everyday life. Like the other day when we were going to go on a picnic, we needed to buy a cooler. But we wanted to make sure our cooler could fit all of our sandwiches and all of our drinks. So I wasn't going to bring my little LL Bean cooler. That's for lunchbox time, was I? No, because that's not going to fit like 5 sandwiches and 10 drinks, is it? No, so I had to go out and buy like a family-sized cooler that would fit all that stuff because the volume, you need to be bigger. Does that make sense?
Yes.
Okay. So, here are a few things we need to talk about. When we're talking about measuring stuff in a line, like a ruler, that's called a linear measurement. So you want to know how many miles it is to get from here to Stanford, or how long of a distance it is to travel from here to Dunkin' Donuts down the street, or how long do we walk when we walk over to the primary, or what's the measurement of the coffee table, or what's the height of my water bottle. That's called linear measurement. But today we're actually going to talk about volume, which is cubic units. And are we in agreement that this little cube, if it was hollow, could actually hold stuff inside of it?
Yeah.
Yeah. So that's what we're talking about when we say volume. It's the amount that it can hold inside of it.
Like
So we're talking about cubic
thing.
units. Yeah, like a little cooler. Or
Like the cooler thing
So
you
that means
said.
it could be like, how big was it?
yeah, exactly. The area of a closed two-dimensional figure is the number of unit squares and, okay, so the volume of a three-dimensional object like this little cube, so everybody should have a little cube in their hand. Go ahead and hold that. The volume of a three-dimensional object, of a 3D object, so it could be this object, it could be this object, it could be this object, it could be your lungs, those are all 3D objects, means the unit cubes, how many unit cubes it takes to fill up the open space. Does that make sense? Or how many, if we're measuring in unit cubes, which are these little centimeter cubes, how many of these little centimeter cubes would it take to fill up a huge one of these? That's what volume is. Or how many little centimeter cubes would it take to fill up my whole water bottle? Or how many little cubic centimeters would it take to fill up this whole room?
So basically how
So
much
volume is how much it... We're all staring at you awkwardly because you know why. So now you need to change something in whatever you're doing and fix that behavior so that way it doesn't happen again. Got it? No. Okay, so volume is how many cubic centimeters it takes to fill something up. Does that make sense?
Yes.
Okay. So let's hold up a little, everybody hold a little cm cube. Hold a little cm cube in your hand. Now, what is the linear measurement of each edge of this cm cube? What's the linear measurement of this cm cube? Tell your partner.
1 centimeter.
So 1 centimeter. If I were to get out the ruler and measure just an edge. Okay, so we're in agreement. So the volume of a centimeter cube, because if we were to measure the edge and the face and how high it is, the volume is, does anybody know? Zach?
Centimeter?
The volume is 1 cubic centimeter. 1 cubic centimeter.
What is that?
Tracy?
You measured all 1, 2, 3, 4, 5.
I'm still hearing noises over there. Yep.
Would each one equal a centimeter, or
Yep.
does the whole thing equal?
Each one equals a centimeter, but in order to fill this whole guy up, you can only fill this whole guy up with 1 cubic centimeter.
Okay.
And that's what we're talking about today. We're not talking about adding up all of the sides and just the surface area. That's not what we're talking about. We're talking about how much it takes to fill up this little cube. Whoa, 1 cubic centimeter. All right, well, let's now... you don't have a big cube? Actually, let's do this one.
Oh,
This face.
that looks like a big. That looks
So,
like a big of a cube.
How many cubic centimeters would it take to fill up this shallow base 10? So go ahead and talk to your partner.
100.
Oh, good. 100.
I did that in a math box.
That one's pretty easy because it's like a slice.
Yeah.
It is.
How many? And that's why some of those math boxes are hard, because we haven't gotten to the lesson yet. And they just want you to get ahead. Yeah, they want you to figure it out. How many cubic centimeters fit into this big cube? Tell your partner and tell them how you figured it out.
Because
And do it
double
And this is what I'm going to say to you. You need to prove your answer by using maybe some longs or the little cubic centimeters that you have at your table. You need to prove your answer using the materials I just gave you. So do that with your partner. Did you hear what I just said?
Yeah.
So
Zach
prove
said
it
what?
with him.
Well, I don't get how to prove it. Like, what do
Use
you
your
do?
materials.
You build?
You won't be able to build the whole thing because we don't have all those materials, but you'd have to use this to talk about it.
So what would you keep on adding them up?
I don't get it.
Like, you need to show me with the materials I gave you.
Oh,
how,
like spread out like 10 centimeter cubes.
Yeah.
And then build the base.
Yeah, and you won't be able to have a full base. You'll just have to pretend.
Okay.
Wait, can we use that for a second?
Sure.
Wait, are you talking the inside too?
That's what volume is. Yeah.
Yeah. But 1, 2,
Volume is pretty easy. Yeah. It's heavy.
That's what volume is.
It's 10 times 100.
All right, Gavin, do you have... But remember, we're not measuring up the sides. We want to know how many of these little cubes it takes to fill up that whole big cube.
Oh,
And I want you to prove it by using the materials you have. Ooh, Sam. Will you come up and show everybody what you're doing under the camera? That's what I'm looking for.
That's what
you were trying to say, right?
Yeah, but we don't have that.
Don't worry about it.
That's what I was thinking.
Don't worry about it.
She counts it like that.
So wait, show us what that first flat is on the top. What's this?
This is 100.
Okay. Wait, Sam, not everybody's being respectful of you right now, so I'm not even going to tell you to wait. I'm just going to stare at those people and hope that they sit down and turn around and look at you. Oh, good, I didn't even have to look at them.
It goes 10 times, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So how many little cubes would it take to fill up that block if it was hollow?
1,000.
1,000.
Because it's 100 times 10.
Yes. Who needs help understanding that?
What did you want to ask me?
Nothing.
Oh, you said Gavin.
Okay. I need some meter sticks. So, well, let's pretend. Let's just pretend they're meter sticks. For the sake of, is that it? We only have one over there? Why?
Oh, I'll go get them.
Because he accused me of taking his, which I definitely did not. That's fine. We don't need them. Okay, bring that up.
He took ours. Yeah, he took ours.
Well, okay, let's pretend this is a meter stick.
Yeah, you did.
I said he could borrow them.
Yeah, but
I didn't say he could take them forever. I said he could borrow them, and when he came in here, he eyeballed them like, where did those come from? And I wanted to say, those have been in this room since the day I moved in here. Which I have no problem sharing, but right now would be a moment when I would need them, right? And I'm not going to use the ones that have the sign. So I guess I'll just show you what I was going to do, because I actually did get to do this with the kids last year, but we don't have all of the sticks, and you know what? That's okay. I'm going to show you in the secret
I have an idea.
teacher book.
We can take a piece of paper and cut it that long.
We could, but you know what? That's okay. We're not going to worry about it.
Why are you showing us this?
I'm not.
It's not the answer.
It's not the answer. It's not the answer. Do you notice how my tone of voice has just changed? Because some people are starting to get goofy.
It's just like a helping thing.
And it would be easier if I had my yardsticks. So here are the directions. Place 2 meter sticks on a flat surface at right angles to each other. That's why I'm just showing you what the theory would be. Hold up a 3rd meter stick perpendicular to the other meter stick so that all 3 sticks meet in the corner. So see? Like this.
I wish we could do that. Can we do them with rulers?
Oh, we can do it with
we could do them with rulers, but wait. Before we do it with rulers. So, with the help of this partial frame, I want you to imagine a cube whose edges are the length of a meter stick. The volume of this cube is 1 cubic meter, which is going to be huge. We can't really do it with a ruler because it's going to be too tiny.
What about
these? A ruler's too a ruler. Those are too tiny. It has to be a meter stick.
Can we go get some from Stroud? give us a special key. Where?
Let's just see if we can use these ones with our signs on them already.
Oh, yeah.
We'll just have to be really gentle with our signs.
But those are yours.
Are they yours?
Yes. Yeah, those are yours.
Mr. Eller took 2 meter
They're
sticks.
fairly similar.
Well, one of them's a meter stick. Yeah.
They're fairly similar.
Yeah,
So let's pretend if this one were to stick out here,
you could put it upside down.
and then this one were to stick out right here at the very edge of this sign. Who wants to hold this? Come on, Gavin. Hold this one. No, I only needed one volunteer. Yep, and then this one. So this is a partial frame because we're missing a frame for over here. That would go over here. So look how huge that is.
Yeah. Wow.
That is
Almost taller than me.
That's pretty cool.
huge. A cubic meter.
That will
Cubic
be
meter.
taller
So
than
you're going to need to remember how large that is.
I have an idea. Wouldn't that
All right,
be
let's put these back.
Don't touch that flag, Chloe.
Wouldn't that be like 100,000 of those big cubes?
Yeah. No, of the big cubes?
Well, yes.
Well, how many big cubes are in 1 meter?
Well, it still works with these,
Well,
but it's too
there's
small.
more.
Yeah, but that's what you have to figure out.
Oh.
Okay. Wow. So that's huge. That's called 1 cubic meter. What I'm going to give you and your partners, and I've only given you, Ellie, I will give you, since you guys are in a group of 3 today, I'm going to give your group 1 extra one, and you can decide.
And 1 extra what?
I haven't shown you yet. I have to find it.
Hopefully it's got something bad.
No, it's not something bad.
Something
I want you who's this, Ellie? Thank you for letting me borrow that.
It's something math related, that's all I know.
Yeah, if I need to find it first.
Can I put this away?
Yep, you don't need it right now.
Sam's building stuff.
Well, actually, in a minute, Jake's going to go around and collect all of the materials that we just had out.
Does that get like
And
cube?
nope. Ellie, you know what? My answer this time is no, and I know that I'm recording this lesson, and people are nobody's really gonna watch it. But if people do watch it, they'll hear me say no, and they're gonna think, wow, she's so mean. And then I'm gonna say, no, I'm not. I made that child go before math started.
That's recorded.
Because of that reason. So it's not that you don't have to go, it's just that you want to leave in the middle of math. Okay, so what we've got today is a grid paper, and you and your partner or partners are going to work on creating a cube, and it can be any size you want. But I want to show you something. And I see some people right now that aren't paying attention to the best of their ability, and they really need to. And I'm not going to stop. I'm just going to... Is it that time?
I'll be back. Well, no, I just was coming in early, but I'll be back in a minute.
Okay, thanks. So here's an idea. Here's the rules of making your cube, because you will have to cut them out. Oh, Jake. Okay.
Shape now. Right now.
Then go ahead. Go ahead, honey. That doesn't help me. You're placing that right on top of my answer book that I'm reading from right now, and these little pieces are going everywhere. So instead, you need to put them somewhere. Okay, here are the rules.
And now you're in the way.
Right, now you're right in the way. On a sheet of centimeter grid paper,
What?
draw a pattern for an open box. So here, I'm going to show you what a pattern of an open box looks like as soon as this space is free and clear and I don't have things flying everywhere at me.
Can Gavin come with us?
Yeah, Gavin can go with you, and then Gracie and Ellie. Well, no, Gavin's going to go with Sam, and Gracie and Ellie will work together. So here's an example of what this open cube looks like. And I'll zoom in. Grace, you can go sit. Thanks. Do you see that? So it has to be, the walls have to be 2 centimeters. All the walls have to be at least 2 centimeters high. Do you see that?
Yep.
So on this piece of paper, then you can make it as wide as you want or as narrow as you want, but the walls have to be 2 centimeters high. So 2 centimeters high. So let's say I make this wall 2 centimeters by 1, 2, 3, 4, 5, 6, 7, 8. And let's say I make the inside, I'm going to make this a long box, like a shoe box. So I'm going to stop here.
Are we going to get one of these?
Yeah, you're going to get one of these. So I'm going to do 1, 2, wait a minute, did I do that right? Yeah. 1, 2, 3, 4.
You're making your own?
I'm making a pretend one right now, just to show you.
Are we going to make...
Yeah, you're going to make your own. So this is the inside. I'm not even going to wait. I'm going to keep going, but I'm a bit fearful because there are some people who are just not paying attention, who are now distracting their partners. So it has to be 2 centimeters high, but it can be as many centimeters as you want. See how 1, 2, 3, that's 4 centimeters long. It could be 3 centimeters long, 10 centimeters long, that's up to you. But it has to be 2 centimeters high. So over here I have to have 2 centimeters high, and I'm going to make this one the same length. If whatever I do to this side, I'm going to have to do to this side. So 1, 2, 3, 4. And then I'm going to make these 2 walls. They have to be 2 centimeters high. Please.
I know.
Hold on. So Sam, go get me some scissors. Let me show you. Yeah, what's your comment?
Oh, it's a rectangular pyramid.
Learning target is multiplication.
Right.
It's the area and the perimeter.
It's the area and the perimeter. So then you'll cut this out.
Rectangular prism. Isn't this a rectangular prism?
Sort of.
Prism?
No.
Rectangular.
It is going to be a rectangle because I said I wanted to make it long, like a shoebox. But the only rule is that you have to have your walls 2 centimeters high.
So first you draw like an original rectangle, and then you draw 2 centimeter high things around it.
Yeah, and they can be as long as you want.
Okay.
But then you want to figure out, once you cut this out, how many centimeter cubes, and here's this is a centimeter cube, how many centimeter cubes you would need to fill into your newly made box.
I have a question.
Hold on.
That's why they have a sandbox.
Now you could, that's exactly why they have a sandbox in there, because it's like a sandbox. You could tape this, but you do not need to fully perform this whole thing. You can create this without figuring out how many, without having to fold it all up and tape it together, how many cubic centimeters would need to be fit into here. Because what you would just figure out, okay, well, I need at least 2 layers of this completely filled up. I need at least 2 layers
Can you do
of this.
Can we make your own?
Right, that's what you're going to do. You're going to make your own in just a minute. So, but is this all the way full?
No.
No.
No, like another layer is going, so 3 more centimeters cover on the edge.
Yeah, so I have to do one more layer because remember I told you have to have 2 centimeters high. So that's 2 layers. So do you see how I still have I need a whole nother layer on there?
We made these like with
Science.
Can we do it more than 2 centimeters?
No, you have to do 2 centimeters high. That's the only rule, but you can do it however long you want. Okay? And you and your partner only are sharing one piece of paper. I will get the homework out, Mrs. Therian.